Hello everyone, in this video we are going to learn gas stoichiometry, right? How to do gas stoich problems. So let's get started. So first of all, we'll just go over these conversion factors, right? So we'll be using that throughout this worksheet. So you should know that 1 centimeter cube is equal to 1 ml and 1 decimeter cube is equal to 1 liter. Right, so let's start. I'm going to do problem number 1. So in this problem you are asked to calculate the mass of MgCO3. So it says hydrogen sulfide occupies this volume at this temperature and standard pressure. If hydrogen sulfide reacts with MgCO3, what mass of MgCO3 is required to react with all of the hydrogen sulfide? So you are asked to calculate the mass of hydrogen sulfide. So first let's write down the reaction. So H2S reacts with magnesium carbonate, right? Mg is Mg2 plus, so magnesium makes 2 plus and carbonate is 2 negative. So if you do the formula, it becomes MgCO3. Right? Now hydrogen sulfide will make H plus ion and sulfide is 2 negative, right? So this is a double replacement reaction. So do the crisscross again. So this hydrogen will go with the carbonate and you will write down the formula as, and the magnesium will go with sulfide. So magnesium and sulfide will form one product. Since they both have charges 2 plus and 2 negative, so the formula would be just MgS. And then H plus will make a compound with carbonate. So do the crisscross and you will get the formula for hydrogen carbonate, which is also known as carbonic acid. Then balance this equation. This equation is already balanced, right? So no need to balance this equation. So now let's start the problem. So let's write down what is given to you, right? So we have volume in centimeter cube. So volume is given to you in centimeter cube. So that is 278.2 centimeter cube. Right, now remember 1 centimeter cube is 1 ml and 1 ml can be converted to liters as well. So let's do this conversion first. So you start with 278.2 centimeter cube, convert that. So we are going to go from centimeter cube to liters, right? So you start with centimeter cube, convert that to milliliters first. So 1 centimeter cube is 1 ml. Now I know how I can go from milliliters to liters, right? So 1000 mLs equals 1 liter, right? So you can cancel the units, milliliters with milliliters, and you get your volume in liters. So volume comes out to be 0.2782 liters. Right? So now we have the volume. The pressure is given to you. It says standard pressure. So P is 1 atm. Right? And then we have the temperature. Temperature is 26 degrees Celsius plus 273. That comes out to be 299 kelvins. Right? So we have volume, we have temperature, and we have pressure. We can solve for moles. Now we are going to apply PV equals nRT, right? And then we can rearrange this equation to solve for N. So N is equal to PV over RT. So this is the equation where we are going to plug in the numbers to calculate N, right? So let's plug in the numbers. What value of R are we going to use? Since the pressure is in atm, we can use R equals 0.0821 liters atm over Kelvin times mole. So let's plug in the numbers. So N comes out to be, P is 1 atm, volume is 0.2782 liters, and then R is 0.0821 liters atm, and then the Kelvin and mole are going to go in the numerator. So I'm going to just write times Kelvin times mole. So this part comes from the R units, right? And then what do we have next? We have temperature. So times temperature is 299 kelvins, right? So now you can see all the units cancel out. So atm cancels out with atm, liters with liters, Kelvin with kelvins, and you get your answer in moles, right? So N comes out to be 0.01133 moles. Okay, so this is N, right? Now since we already got the moles, we can convert that to mass of MgCO3, right? So these are the moles of hydrogen sulfide. So all this calculation was for H2S, right? So we have the moles of H2S, right? Now we will start with the moles of H2S, that is our A, and we are going to go to moles of MgCO3, right? So we will start with, this is A, so this is A and this is B. We are going to go to moles of MgCO3. So let's start. So we start with 0.01133 mole H2S. Convert that to moles of MgCO3. Since the mole ratio is 1:1, so I can write 1 mole H2S equals 1 mole MgCO3. Next, convert 1 mole, the moles into grams. So 1 mole MgCO3 is equal to 84.36 grams MgCO3. That's the molar mass. So just double check. You can cancel out all the units now. So moles with moles, moles of MgCO3, and you get grams of MgCO3. Okay? And then you can plug these numbers in your calculator and get the answer. The answer comes out to be, I think it's 0.956 grams. So that is your answer. Okay. Next, we are going to do problem number 4 on the same worksheet, number 9, on gas stoic. So let's do question number 4. So this time you are given decimeter cube as the volume of ethane. So first step, write down the equation. So C2H6, that is the formula for ethane. You can look it up because this one does not state the formula, but this is ethane, C2H6, plus O2. This is a combustion reaction. The products are always CO2 and water. Next, you need to balance this equation. So you will get 2, 7, 4, and 6. Now let's write down all the variables. You have volume. Volume is given to be 14.4 decimeter cube. Now since 1 decimeter cube is equal to 1 liter, you can assume that this is equal to 14.4 liters. Okay. Then we have temperature, which is 102.7 Celsius plus 273. So temperature comes out to be 375.7 kelvins. Then the pressure is in kilopascals. Either we can use kilopascal value of R, which is 8.31, or else we can convert the kilopascals into ATM in order to use the value of R, which is 8.0281. Right? So let's convert the pressure. So pressure is 99.3 kilopascals. Convert that into ATMs. 1 ATM equals 101.3 kPa. 101.35 kilopascals is equal to 1 ATM. If you solve that, P comes out to be 0.98 ATM. So now we have volume, we have temperature, and we have pressure, right? All in the units of R. So we can use R equals 0.0821 liters ATM per Kelvin per mole. We already converted the pressure into ATM value. Okay, so let's plug that into PV equals nRT and solve for N. Since N is equal to PV over RT, pressure is 0.9198 ATM. Then we have V volume, which is 14.4 liters, and then we have R, which is 0.0821 liters ATM per Kelvin per mole. That goes in the numerator, so I'm just gonna write Kelvin times mole. Okay. And then we have T, which is 375.5 kelvins. Now you can cancel all the units. ATM with ATM, liters with liters, kelvins with kelvins, and you get your answer in moles, right? So N for ethane and ethane comes out to be 0.458 moles. So this is the moles of ethane, right? But that's not what we need to solve for. We need to solve for how many grams of water will be produced, right? We already solved for moles of ethane. So let's convert moles of ethane, which is your A. So ethane is A, and you're solving for water, that is your B. So you're going from moles of A to grams of B. So convert moles of A to moles of B, then moles of B to grams of B, right? B is water. So let's set up the dimension analysis. You start with 0.458 moles A is ethane. Use mole ratios from the balanced equation. So water is 6 moles B over 2 mole A, right? And then convert the moles of B to grams of B. 1 mole water is equal to 18.02 grams B. Cancel and you get your answer in grams of B. So this comes out to be, if you solve that, it comes out to be 24.76 grams water is produced. So next I'm gonna do question number 7. on the same worksheet. Excuse me. So question number 7 is, you are given grams of zinc are reacted with excess of hydrochloric acid at standard pressure. The standard pressure is always 1 atm, right? What is the temperature of hydrogen gas produced if it occupies 2 decimeter cube of volume, right? So first step is you have to write down the equation. Now since zinc is a metal, it reacts with HCl. HCl is an acid, hydrochloric acid. You can look the formulas, or you have to memorize, right? Remember I told you to memorize all the acids on the back of the ion sheet, so you can memorize the formula. Now since it's a single replacement reaction, we have one element and one ionic compound, right? So zinc will make Zn2 plus and Cl is 1 minus, H is 1 plus. This is how the acid will split, right? So zinc will kick out hydrogen from the salt and make a new compound with Cl2, Cl negative, right? So zinc will make a compound with this and hydrogen will come out as H2 gas, diatomic. So that would be zinc chloride plus H2. Then you balance this equation. I only need to put a 2 here. Now this equation is balanced, right? So first step, you write a balanced chemical equation. Next, you start with grams of zinc, right? And you are going to go to the temperature of the hydrogen gas produced. So we would need to calculate the moles of hydrogen gas first, right? So let's start. So you will have to first start with grams of A. So zinc is A, and you are going to the temperature of hydrogen gas. For that, we have to first calculate the moles of hydrogen gas, right? So hydrogen gas is B. So this is B. So you are going from grams of A to moles of A, then to moles of B, and then to grams of B. Okay. So let's first solve for moles of A. Okay. So you start with 34.6 grams A, that is zinc. So A is zinc and B is H2. Right? Convert that into moles of zinc. So we have 1 mole zinc is equal to 65.39 grams zinc. So this comes out to be 0.529 mole zinc, right? Next, you need to convert the moles of zinc to moles of hydrogen gas, right? You can just go it directly in one step, right? You can just write down the mole ratios and go directly to grams of B, but we don't need the grams of B yet. First we need the moles of B, right? So let's convert moles of A to moles of hydrogen gas first. So you start with 0.529 moles A and convert that to moles of hydrogen gas. So mole ratio is 1 to 1. So 1 mole H2 divided by 1 mole zinc. So I can write zinc here. So this cancels with this and you get moles of H2, which is also equal to 0.529 moles H2, right? Next, we have the moles of H2 now, right? But we are asked to calculate the temperature at which it was collected. We have the volume and we have the standard pressure, right? So let's calculate the temperature. So pressure is standard. So at standard pressure, which is 1 atm, and temperature is what we are solving for. Volume is 2 decimeter cube. So volume is 2 decimeter cube, which is also equal to 2 liters. So we have volume, we have pressure, and we have number of moles. N is 0.529 moles, and we can solve for T, right? So let's do the calculation. If you rearrange PV equals nRT to solve for T, T comes out to be PV over nR. Plug in all the numbers. 1 atm times 2 liters divided by R is, N is 0.529 moles and R is 0.0821 liters. atm, and then mole and Kelvin go in the numerator, right? Now cancel out the units that get cancelled. So atm with atm, liters with liters, moles with moles, and you will get your answer in kelvins. So if you solve that, you will get 46.05 kelvins. So that is it for this video. In the next video, I'm gonna do some problems from worksheet number 10.